Thanks for coming to this session. This is about runtime resilience, scalable PHP. I'm Paul, and this is me from my LinkedIn. And I do open source things. And I contribute to things like PHP, Fig stuff, PSRs. I do training, consulting, and contribute to open source projects like Jenkins and Dagger, and I Linux Foundation. And I gave this talk at SymphonyCon in Amsterdam. Well, the previous version of the talk. This is the latest version of the talk now. So professionally, I do these types of things, and it keeps me busy. And I have acquired lots of experience in scaling PHP systems, not just scaling them, but tuning them, monitoring them, analyzing them over many years. And I also organize conferences. So the UK PHP conferences and Scotland PHP. And skip this one. So I'm 38. I've been doing PHP for 24 years. I've acquired lots of knowledge in this time. Some things useful, some things not. But the point of this talk is to basically share with you all of my knowledge that I've learned. Yeah, some of it anyway, right? So I specialize in tuning PHP systems, but in order to tune a system, you need to measure the system. And then once you're good at measuring systems, then you can change how the architecture is and stuff like that. So this is what content from this session. And I do this stuff for governments and banks and big companies. So that's the context. I founded ByteHire. ByteHire is a tech company, and we do recruitment, basically. Rather than recruiters, you come to us for anybody. And we do 90% of all the screening and validation, technical validation up front, or you and your development team need to get involved, basically. So today's session is from the internal systems of ByteHire, scaling that. All right. The agenda is things like this. So Zend engine things, OPcache, FrankenPHP, monitoring, visualization, stress testing, architecture, and stuff. So I have a stop clock here. We will see how much content we can get through in this time. This is recorded, so hopefully you can go back and watch it again and catch stuff. So just a little entry. So in the engine of PHP, there's also weird things that maybe you've never seen before, heard of. There is no one single thing to make your systems go fast or scalable. But there's lots of small things you can do that accumulate to being, to being more performant, right? There's this thing called the detect Unicode, right? You turn it off, it's on by default. Unicode, it checks the files if they are Unicode files, but you don't need Unicode for everything. You don't need the emojis or smiley faces or anything like that weird stuff in your PHP files. So why do you need to do this extra check? So manual Unicode handling, but you can, when you need Unicode, you can turn it on, right? It's all good, just for that one file or something. Anyway, so there's one. Another one is sessions. So all of your systems, they will have a user interface and they will have an API. But the point is, when you turn on your application for the web interface, you're also turning it on for your APIs. But then you don't need it for the APIs because APIs do not have sessions, so it doesn't make sense. However, this will be giving you a penalty to boot up the system, right? PHP has to shut down the request and boot the request again. So you're wasting time, right? You cannot scale because it's trying to do session start all the time, but then you don't need it. So you can turn it off by default. And then only when you're doing it, then when you need sessions, like web user interface stuff, then you can turn it on the fly rather than on at the PHP ini file. So there's a thing to think about, how to architect your system slightly differently for maximum performance. This is the real path cache. Real path is when you take a file, relative path, and you resolve it into absolute path. Or if there's a symlink, it gives it the system absolute path. Now this is expensive because it has to go to the disk, and disk I/O is very slow compared to RAM. So what do? You have a cache, right? But PHP needs a cache size. If the cache size is not large enough for the number of files you're loading or resolving, let's face it, there's lots of files, then you could not be going into the real path cache, and you can be very slowly waiting for the operating system to give you back the absolute path every time, which is very slow. So reading files is slow, basically, or loading PHP files, loading classes, right? So this is another thing to check out and see. This is actually not performance, it's more security, hardening. This is from the Symfony documentation. Basically, this is for security reasons. These are all functions that could be used to do stuff. Some you can just disable them. You don't need them. I'm not going to get lots of performance to begin, but you will stop doing naughty things. And only when you need these functions you can turn on, like process control, right? Fork processes. So it's more of a security thing, right? But it's related to making the system optimal. Yeah, these are just things, right? So there you go. This is about Composer. Now, everybody knows Composer, but everybody is maybe, when they're using Composer on the command line, they are doing like -o or optimize or -class map. Sometimes somewhere, sometimes not. My recommendation is you put it into the YAML file, okay, by default. So most people are not doing this by default. It's only like on the command line they add the flags, but sometimes you forget to do the flags sometimes. So here is the performance gains, and Composer is one of the largest bottlenecks on booting, because of course we need to boot our code base into memory, and that takes time. And so if you put it in the JSON file, then it will do performance every single time. Every request immediately gets faster. So if you put it in the YAML file or the JSON file, you're good. And you can switch to APCU as well, which you can enable, and you will get much faster boot times as well. So I recommend doing a benchmark before and a benchmark after you change these, and you will see how much faster it goes, basically. So there's it. Now Redis, this is a very big one, because we're using Redis for caching of our application data. We're also using it for sessions, right? So every single boot we do, we will probably have a session. And so there is a slow Redis and a fast Redis. Redis uses, when you have PHP and you configure, when you configure PHP by yourself, you can enable Redis IG binary. And when it does this, it looks to the system for a system library called IG binary. And it's basically a high performance serialization format tool mechanism that will give you binary level, rather than just trying to serialize and deserialize payloads by default. It will do it in a much more compressed way. So it's super fast Redis. So you just enable it, and you can use IG binary, and this will make your application fly. So every time you talk to Redis, caching, reading, writing, sessions, it will go much faster. So, and this is also something I recommend you do for all of your setups. It does require you doing configure, which means compiling your PHP, but to be honest, it's not too difficult once you get it in place and you have all your extensions. Then you can just do enable IG binary, and then you have your PHP ready to go. So, a little bit extra work, but a huge gain in performance. And you can have multiple Redises if you wish, and it will do round robin approach. So don't just go to one Redis, go to 3 of them, and then you can read and write. So the weight is equal, but you can have one is like a master and 2 is like slaves. So like a 2 or and 1s, and you can control the reads and the writes as well, which will also improve your read and write performance. So you write to the master, and then it will you can read from the slaves, basically, something like that. Just Google this. Is also for. If you improve your Redis, you can also improve the availability of the Redis to be one. If one is getting lots of load, lots of writes, you can read from the others. And so that's some things. FPM, of course, I hope everybody knows about FPM already. It's quite mature technology for PHP. And the point is here is, if you get to max children, you have to fork a new process. Just moving this Zoom thing out of the way. I don't know if you can see the Zoom thing, but I'm trying to move it. Okay. Anyway, yeah, this is FPM. We wait, right? If we hit the max children, you have to fork a new process, or we cannot fork any more processes because we're in the max children. So anyway, FPM has something called a status path. Okay. So if you don't know about this, it's basically metrics. How do you measure your FPM? These metrics you will not get from out of the box, like Datadog or New Relic or some of the Laravel things. They will not go into this much detail. They will just say this is the time of your API endpoint, or the time of your web page, or your database call. It will not really go to the detail of your FPM engine, and that's where you should be optimizing, because once you optimize database, or when you're scaling up, scaling down, or whatever, then or trying to maximize the hardware available, then sometimes you can actually reduce the number of machines you're using. You can reduce the hardware, or you can just get more traffic for the same machines, because what you're doing is tuning, right? So this is a bit tuning hardware. This part of the talk, tuning the PHP-FPM for the hardware. So when you go to this URL, you get this output, and it's real time. Okay, so there's your children, processes, all this stuff is going on, right? But it's not really useful. It's just a default format. So PHP has a thing here called FPM exporter. It's part of this project. For context, sorry, one sec. Context, I have. Second. So this is a project. I have this on GitHub. I will show you in a second, the GitHub project. Anyway, there is a YAML file, and these are all the things inside there for you to use. And here's FPM exporter, right? So it's listening on port 9000, or this port actually, and it runs in its own port, this port, and it's pinging your application, right? FPM status, that's the thing I just spoke about. Okay, so it pulls it in, and it pulls in this data here. But the purpose of this exporter tool is it will produce output looking like this. And this is a key part of this session, because this format is a special format. All right, this is all the low-level information metrics, but it's in a special format called OpenMetrics. And OpenMetrics is kind of like OpenTelemetry and other things. Basically, it's an international standard for metrics exporting and metrics importing. So if you can export it, this tool is an exporter for the OpenMetrics. You can import it into any popular tool, right? Any platform can have it, especially the open source ones, such as Prometheus, which is very popular, right, to store your metrics. So, yeah, so I'm going to pause there. This talk is a lot about live demos, actually, rather than slides, but here we go. So, FPM. So I'm just going to give you a little bit of a rundown on this repository. I will share the URL at the end of the talk, and you can have it. This is a workshop, so you can actually run this, take all my knowledge, all the configurations, and bring it to your projects. Okay, so it's like a follow along guide. This has a Symfony demo application. Is the app, right, that we're running against now. FPM is here. What did I give? Okay, so here we are. This is where the slides were. So this is the mathematics on how you calculate your max children, right? It's the number of RAM you have available, and then the average process. So if you have 10,000 megs of RAM, and you're using 100 meg of RAM, then you can do 10,000 by 100, and you have 100 processes you could have, right? Children. Not really, but that's the point, right? So here, how do you calculate this? So here is this link here. It's the FPM calculator, and you don't have to do the math yourself. You can just say I have 16 gig of RAM available for, maybe the machine has 24 gig of RAM for the operating system, but you want to say give 16 to FPM, and maybe a buffer in the back, and 10%, and then processes are maybe 100 something like that, right? So there you go, and then this will tell you the values to put into your FPM. Okay, so again, don't worry about this URL. It's in the README, so you can take it. Okay, so there's a cool thing. Next, so the repository has a load testing tools built into it for you. So first of all, I'm seeding a database here of products, customers, and orders. So we have some things, some data in a database, okay? And hello. We had internet problems, so we had to disconnect. And now we're back. I hope you can see everything okay. Apologies for the internet problems. Anyway, we're back. So I was just saying this test project that I've created for you, it's as a tester, you can pull down Docker images and then you just do makeup and you're ready to go. And then migrate and seed. So that's what we were just doing there before the internet cut off. So it seeds the database, okay? So after that, we have a Symfony application. There you go. Next, we're going to talk about deeper FPM things. So there is a case 6 we're using for load testing, all right? So you can run this. It runs. While you're doing this, you can check the FPM status. You'll see it's changing, refreshing, bing, 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 bing. It's the real time, all right? So that's the load testing tool, okay? K6, it's in the repo. Next, so the exporter is up. We can bring up the exporter. That's the thing that exports the OpenMetrics format. Okay, it's up. Is it running? Yeah, it's running. You can check it. There you go. Refresh, refreshing. And now you have your exporter. Now you have metrics. Next, what do? You put it into Prometheus. So we have a Prometheus. Bring it up. It's running. Okay. Check. It's up. Okay. So next, like this, it shows you your targets. Okay. This repository has lots of things to show you to give you demos of. This one we care about is this. So it's pinging / metrics, right? Metrics is the exporter tool, and it's getting these OpenMetrics format out, which is this one. This is metrics here, and it's pulling these down into Prometheus. Okay, and we can run the K6 again, benchmark, and we will be getting stuff now. So that's now going into Prometheus. Next, we want to bring up Grafana. Okay, this ships with Grafana. You can run it, bring it up, and it's running. Okay, the username and password is Symfony for this one, because I made this for the Symfony conference, and you can log in. Okay, on this repo, you have dashboards. The dashboards are actually inside this repository. You can take them, they're JSON files. We made them. So at ByteHire, my company, we can we created our own custom dashboards because the open source ones were not very good. So here is multiple dashboards for you. So you have FPM and FrankenPHP dashboards and stuff. So, but they already put up to Grafana, and then this is the directory where it has the dashboards. So you already have them by default, and you just go to dashboards at the top, and so here is the FPM dashboard. Okay, and here is things. Okay, of course that's nothing new. You know, maybe you get this already with your Datadog, New Relic, but there's something interesting in here called OPcache metrics. Okay, and this is what we created. And this is a very important thing. Okay, so let's go back. Let's go now. Move it over to OPcache and stuff. But before we go to OPcache, I want to show you some things. So these are commands that's in this workshop repo. That is how you do tuning. So when we're running I will go inside the container. So when we're running the benchmark, right, you can do things. What is the average amount of memory per process? If you remember the mathematics of the calculator, how many children do you need? Well, you need to divide the RAM available by the average process memory to get the number of children to be maximizing your hardware. Or what is the total amount? So if you run simulation tests, you can see what is the total amount of RAM your application needs. And this is individual ones as well for like benchmarking, tuning, seeing any weird stuff. So, and you can get you can find the most memory intensive process and find out what your max RAM should be. So you're never hitting below that. Otherwise you'll get out of memory errors. So if I run this now, and take this one. So I run the benchmark, and now I run this. Here you go. So this is it's different. So it's like 33, 34 megabytes of RAM, all the different processes I have. Okay. So you can see that. Maybe what is the highest amount, this one. So rerun again. And right. And so this is like the number of megabytes, right? 36 megabytes. So you probably want more than that for your application to give it more time. Okay. So that's some tips on how to do tuning and debugging of FPM and the metrics and all that sort of good stuff. And yeah, you can watch the metrics in real time. Okay, so that's FPM. Right. Now let's move over to OPcache. OPcache has a dashboard you can run, okay? Because there is a difference between what is in the init, the php.ini file, and what's actually happening in production, okay? So bring up the dashboard and go here, and boom, here you have a dashboard. It's a tool, standalone. If you want this in production, you're going to have to add a Nginx password to access it. Right? You don't want this to be public, but it's got some good stuff. Okay, I have the FPM application, and I also have the Franken application as well, which is not running right now, of course, but it's part of this setup we have made for you. So there's that. Let's go to the slides. Okay, so OPcache. Let's talk a little bit about this. So Zend Optimizer, it's shared memory, right? You load a file, you load PHP code into memory, and then that shared memory is shared across all of the processes, so you don't have to do it again. That's it, right? But you need to make sure you have enough memory you're allocating. Otherwise, it will not be cacheable, and you will get these things. 1 second. Here, you will get something called a cache miss, key hits, right? So there are actually some, maybe I'm not provisioning enough RAM for my OPcache, so there are files not hitting this. So this is where you will know if you need to allocate more RAM or not, right? Pre-used as well. You can see if you're hitting this, or but there's also RAM, but there's also just number of keys, right? And we will translate this back to a setting in a second. So these are some of the settings. You may have known these and be familiar with these, but the important ones are your max accelerated files and the memory and the string buffers. These three are important, right? Now, and the fast shutdown, just turn it on, right? Don't worry about it. Now, max accelerated files, this is a tricky one, right? Many people, there are some things about this they don't know. So max accelerated files is how many files you can put into OPcache, but that is how many files are you loading on your project. So here is the command to see how many files are in my project, this including the vendor directory, right? I go to the vendor directory and I run this. I have this much, okay? So this is number of files in your project. Now, the thing that's the knowledge I have in my brain that's useful for this talk that you may not know from the documentation is that this value actually has to be a primary key. No, not a prime number, a prime number, right? You go to the documentation, prime number. Now, basically, the point is if you do not give it, if you just make a random value, then PHP will have to calculate what is the nearest prime number and then change to that, right? So, for a performance optimization, set it to one of these values, is my point. Yeah, otherwise it will be having to do prime number shifting. So there is something that maybe you didn't know, prime numbers. Strange things, right? PHP. So, and then, yeah, you just check. So this is my 9440 is my files. This is my 10,000. So the point of this is you need to set this to be much higher than the value. Now, why? When you're adding composer libraries, the size of your vendor directory the size of your vendor directory will be increasing and increasing and increasing. And of course, if the number of files you're loading is greater than the max selected files in your PHP any file, you will basically stop caching. OPcache is enabled. It will not be enabled for every file. And this is where you need to be aware. So if it's 9,000, then I would set it to maybe 16,000 because that's the next prime number above my value. This means you can keep adding projects and files and composer libraries and you will not get to your limit. Okay, so set it way higher. And that's the point of OPcache and max accelerated files. So there you go. Let's go over to the repository again. So, OPcache. Here we go. Okay, so this is the dashboard, right? This is what you could use, but I don't recommend this in production. Here we go, down here. Okay, so in this project, we created an OpenMetrics exporter for OPcache, and here it is. Okay, so you can take this and you can add it to your projects as well. This is a custom code that we added. We are just reading the PHP and then we're outputting on a Symfony controller. We're just outputting this stuff. Okay, so this is what you want. You want this out of your system as an OpenMetrics format, and that is being consumed by Prometheus. So Prometheus has an OPcache up point. So if I go back to Prometheus again, you will see it's kind of part of here actually, right? So it pulls everything in one go. So now so this is the FPM metrics, and this is the OPcache metrics. Yeah, different jobs. Okay, so now Prometheus is pulling them, and that's that. So now if you go to the dashboard, this is how we see it, and this is where you'll get your stuff. Okay, enabled. Hitting. So I know we had this dashboard here, which is kind of okay, but it's not really what you want for production. Production, you want this guy, and this is part of my company's my byte hire Prometheus Grafana dashboard. Okay, and you can open and close, and you see run the load test, change some system things, see before and after. Okay, in terms of string buffer, we didn't talk about this, but just making sure you have enough. If you're hitting the limit of it, then the whole OPcache will die, right? You have to make sure you're tuning it. And there you go. So this one is nice percentages, right? You're only using 15% of the memory. Okay, so there's OPcache. Some things. Next. Just go to check on Zoom to see if there's anything in the chat. Nothing. Cool. All right. Next, let's go to FrankenPHP. So FrankenPHP is the new FPM basically, but importantly is about measuring FrankenPHP and measuring your Franken system, and then creating before and after metrics when you're adding Franken into your project to show how much RAM it's using, less RAM, less CPU, or it's faster, right? Before you can do that, you need to have tuning. Now, at the moment, there is no way to do very good FrankenPHP tuning in production. It did not exist. Why my company, ByteHire, we had to create it, and we have open sourced it. Well, it's open source as in it's in this repository, right? That's it. It's the only place in the world. You cannot go to Grafana and download a dashboard for this. It only exists in this repository. That's why you can take it and you can drop the JSON file here into your project and to your Grafana and paste it in JSON. It's this one. Right? You can take this JSON file to Grafana, and then you do like add new dashboard, import dashboard, and you paste in the JSON into your Grafana, and bam, you have it ready to go. Of course, you have to configure it, but it's almost ready to go. So let's move on to FrankenPHP. Let's close all this stuff down. Right, Franken. So you bring it up. Nice simple make files. Okay, it's now up. It's up now, 3 seconds ago, and it's port 8080. So this is different from the other one that was at FPM on a different port. So this is the Franken one running, and we have Prometheus pinging the OpenMetrics endpoints for OPcache and Caddy, not FPM, right? So here you go. This is all, look at all these metrics. So there's the Caddy metrics, and then the Franken metrics here, right? So not like number of max children, but all these things, threads and stuff, okay? So it's all inside here. Basically, we took the Caddy dashboard for Grafana and we enhanced it to add in the Franken stuff on top. Okay, so in the Prometheus file here, you see it's pulling, it's hitting Franken on port 2019. Now, rather than hitting, you know, the exporter for FPM. Now, let me show you the Caddy file. This is the things that we learned. That in order to get the metrics out of Caddy or FrankenPHP, you need to add these parts to your configuration file. You need to add this line called metrics, which will use OpenMetrics by default. So you don't need a magical exporter tool, it already does it. And you have to do this admin and bind, right? This is in Docker, so we bind to 0 and 2019. So this is basically the administrator port, right? For scaling, just like we had FPM with the calculator to calculate the max children based on the RAM, this is the number of workers, right? Basically. So you take your 2 workers per CPU and then you do the math and you get like an optimal number. So this num is basically the number of workers, which is basically like max children, right? So that's how you do that. And you can have auto or stable mode, which is similar to max children in FPM things, and number of threads, number of workers, right? So that's the kind of the math there for that to help you understand. So now that 2019 is exposed, then 2019 gets pinged here by Prometheus, and then it pulls it. And if I refresh, see it's up now. So Prometheus is pinging this, it's getting the Franken metrics out, as well as OPcache inside of that as well. Yeah, okay, cool. So we can, here's the benchmark for the Franken stuff. We can run this. That will do its job. And then you can get a report thing, case 6. It's not really useful, in my opinion. So now you can go back to Grafana, dashboards, and now you'll have a Franken dashboard. And boom, it's starting to kick in. It should do, anyway. Let's check, see if it's working. Yeah, it's kind of up. So this is OPcache metrics coming out of Franken through that matrix endpoint that we created. And these are the workers and stuff. Now, just to 5 minutes. The thing you need to know about this dashboard setup is there's 2 tabs. By default, it's going to Franken Worker, which is there's like no data, so it kind of catches you off guard. You have to switch it to normal Franken, not worker mode, to see the data. Basically, heads up, this was a gotcha. We spent a long time thinking, why is our system broken? Actually, it was because we didn't choose this. The thing was working fine. So that's that. We can run it again. So maybe this will kick in a second. There you go, it's pinging again more. So anywho, memory usage coming in and out. See your memory. So we're using this much memory. Thread utilization. So there's threads, and then you can see a spike. Busy threads. Okay, so this is how you're tuning your setup on Franken, and you just change that caddy file and rerun the metrics, and you will see. And of course, you've got your OPcache, which is the exact same as before. Alrighty. And yeah, you can see it's spawning more threads than we should be doing. That's why it's in the red zone. So, and there you go. So there's Franken on Prometheus for production, or for your local machine, of course. This is important for the business. You can say, hey, the response time is going down, right? Or the RAM is going down with Franken because we want to improve the setup, and we have to give evidence to the business people that it has made a difference. So this is a start on how you can do that. All right. Okay, so Franken has something called worker mode. Worker mode is like super fast Franken, probably a little bit faster than Node.js, I'm guessing. It's using smart workers using Golang, right? So we bring up this worker. Worker has it's the Symfony app, but it's on 8081, not the 8080, right? So this is the worker mode. This is significantly faster than non-worker mode, but you have to test worker mode because it's running all the time, right? It's running like Node.js. It does not, so PHP does not have to start and stop. It just switches workers, so it's very fast, but it can have weird edge cases for long-running processes. So you have to make sure that you test the worker mode very thoroughly. Sometimes you'll have some problems, some memory leaks, maybe some weird stuff. Franken should be fine now. 6 months ago, 1 year ago, maybe Franken worker had some bugs, but of course people have been testing it, using it, and making it better. So it's quite much more stable now. But of course, try. If not, you just switch to the non-worker mode. Okay. So we are exposing Franken worker metrics on this port here. So there you go. That's OpenMetrics, and Prometheus pulls that in. We bring up there's Franken worker now just up because I just done make up worker. So now it's up. Data is going in to system. So okay, back. So run a benchmark. This will run case 6 benchmarks against the worker mode. Bam, that was so much faster than the other one. So you can see the differences right away. Ignore that, and then you can go to this URL which pre-selects the worker, and you'll be able to see. So this is much better, much more healthy looking as well. I guess the other Franken one is not really configured very well for my machine here. But it's much healthier than, much healthier looking for sure. This is the Franken worker stuff, so busy threads and so on. So we can do this again, run it, and run it, and run it again. And then it will, every 30 seconds, it pings, right? So you will start seeing a spike, and you can start to almost tune. Now, this Franken worker dashboard is actually better than the normal one. We just spent more time on this one. So there's extra dashboard things here you'll see. That's not on the other Franken one. To start to see cool things, how fast and slow, right? Thanks, baby. And there you go. So here is the stuff. It's 8 milliseconds compared to whatever the other one was. Let's check. 6, but whatever. It's not real numbers because on a local machine. Anyway, so there you go. So this is FrankenPHP worker mode. It's the fastest way to run PHP in production, and now you have performance ready dashboards and stuff set up to use. Let me see. Anything else? Development mode, you can enable what's it called? This one, auto reload, basically, which is like OPcache, but not, right? Preload. Oh yeah. So yeah, if you make a change to the caddy file, if you're debugging it, you don't need to restart the whole Docker container. You can just type make worker shell. You'll be inside the shell for the FrankenPHP worker, and you can run this command. and it will reload it from the hard drive. Yeah, so you can do a hot load of Franken caddy rather than turning things off and on, and then you can just rerun code, right? Or if it's broken, you can just do make down worker, up worker, and reload it all completely without doing the hot reload. And there's stuff. All right. So there's some things. We have a few minutes left. Let's move to something else. Away from PHP, away from Franken and FPM and stuff like that. So CQRS. Sometimes you can fix PHP, you can fix all the things, but you're done. Sometimes it's the architecture of your application that will be making a difference to how you take advantage of these things. Redis is some Redis is for reading, some Redis is for writing, writing to main databases, but reading from caches or things like this. So CQRS has something called projections, and projections are basically a flat file or a flat data set of the data, but behind that flat data was like 4 or 5 database tables, like MySQL joins, and you have to join 4 or 5 tables or any tables to get some data, right? Rather than doing joins when you're reading the data, you can pre-read the data and put it and write it to a flat projection, so that when you need it, you don't have to go to the source database to get the all the joins of the data. You can just get the flat data instead, which is 100 times faster. Okay, so this project has some of that in here for you as well to take a look at, to see how we did it on this project. So what we did is, we have here. So this is database query against MySQL for joining all the tables, right? All the products. And here is a projection. Projection is much faster because it's reading from a flat cache, not from a database, right? The output is the same. However, if we build projections, this command here, which you can look at the PHP code for, oops. It rebuilt all the projections, so now it's in a cache. And then when you read it, it's instantaneous, bang, much faster than reading. So that's basically that. And you can check the performance and see the differences basically. And that's out of time for like this part here, but I recommend you check out the repository, which I will share the link now. This is running against the products, and then this is running against the projections, which we store in Redis, basically. And you can see on the graph, the Grafana graphs, the before and the after differences. Basically, that's what this is tutorial is showing you. You see how much it's much faster. And yeah, basically this is how we did it, right? With the code, services, orders, and products, customers, and orders. And you can see how we're doing that basically. And these are the endpoints. And these are the endpoints for the projections. Basically, it's in the code. And you can rebuild projections just for individuals. And so on and so on and so on. And there's projections for normal FPM. And there's projections for the normal Franken. And then there's projections for the workers as well. So you can have fun with that. All the code is in the repo. It's all these projection services, right? It's all in the code, nice and clean. So this repository has projection, controllers, product, and so this is the normal one, and then the projection one, basically. So it's all here. Go check it out. Have a play. Okay. Because the point is sometimes you need to change your architecture. And when you read, you can read from a flat projection, and that would probably give you the performance boost you need, rather than as well as tuning your FPM. So that's all for me. The URL for this repository is here. It's me on GitHub, Dragoonis /scaling PHP. Give it a star. See any problems, any bugs, Of course, you can submit pull requests. Some people are making pull requests out to this already, and take it from there. So that is me. I'm going to pause now.